Hello. In this video, I'm going to talk through plotting a quadratic equation by hand using a table of values and a coordinate plane. Now, what you can do is recognize we can look at any given x values we have, and in perhaps another video, I'll talk about how to generate the ideal x values to plot for a quadratic equation. But here, I'm just going to use the ones that I have already pre-written in this table of values. Notice I left some white space in the middle here, and notice the equation right on top. Negative x squared plus 6x minus 5, and then on the right-hand side, I have a coordinate pair of x comma y, as we would traditionally use, and then the blank spots here to write them for the actual points. All right, now some students are always unsure about what to do in this situation, but never fear. Here, it's actually rather structured for us, pretty simple to use. So if you have some x values you want to use, here we have x, and here we have an equation which involves the variable x. X is just a variable, meaning it stands for some numbers which you don't really have specified yet, but we could specify some values. Now, if we're going to specify the value of x, well, we're going to use that specified value in place of x in the equation, meaning for each of these, we're going to have more or less the following. The equation, but instead of x, you're going to leave a blank spot where you're going to use the number you are plugging in, such as follows. In those blank spots, I'm going to go ahead and, in this case, put my numbers. So we have 1 and 1 right there because we're plugging in the number 1 to this equation instead of x. Now I'm going to talk through what this is going to be equivalent to. Well, we have 1 squared, which is 1. Make it negative, that's a negative 1. 6 times 1 is 6. So negative 1 plus 6, that's going to be 5. And here 5 minus 5 is just going to be 0. So the y-coordinate is going to be 0 when the x-coordinate is equal to 1. Now I'm going to be efficient here and just go ahead and list out the other x values. And I'm also going to be efficient by just writing out this expression. Now, luckily, if you're doing this on some sort of computer, you can, or some sort of technology, you can leverage the copy-paste ability, such I'm about to use right now, where you can highlight your given text, or whatever means you can do that, and copy-paste this expression into each of your boxes, or onto each of your scrap paper, or you can, if you're using technology such as a graphing calculator or something like Desmos, scientific calculator or graphing calculator, you can essentially just keep the same formatting and then adjust the numbers inside the parentheses here. Now I'm going to go ahead and post these in. So we have 2, 3, 4, and 5. Crunching these numbers, we have the second expression is going to be 2 squared, which is 4. Make it negative. That's a negative 4. 6 times 2 is 12. Negative 4 plus 12 is a positive 8. Minus 5, that'll be a positive 3. Keep going along. 3 squared, that's 9. Make it negative, it's a negative 9. Here, 3 times 6 is 18. Plus negative 18, or sorry, negative 9, that will give us a positive 9. Minus 5 is going to give us a positive 4. It's a quadratic equation. Hopefully our table is centered at the vertex. In this case, it will be. So I'm going to go ahead and, beforehand, list out those values. Notice the symmetry, vertex, 3 on either side, as we move 1 away in either direction. If we move 2 away in either direction, it now is 0 at each of these points. And we can verify real quick. 4 squared is 16. Make it negative, that's negative 16. 6 times 4 is 24. Add those together, you get a positive 8. Minus 5 is 3. 5 squared is 25. Make it negative. 6 times 5 is 30. Add those together, you get a positive 5. Minus 5 is equal to 0. Now we can go ahead and list these values. So 3, 4, 3, 0. And I'm going to start plotting these points. Now, if you're somebody who can't do that math in your head quite yet, again, calculators are a resource, so you can type in the expression as you see it here, and a calculator should be able to compute those for you. Now, a quick note I'll make about calculators is you got to make sure that you're using parentheses, especially when you are squaring a negative number. If you don't do so, your calculator is going to square the positive number, so it would be like, or sorry, yeah, it's going to square I guess I don't have any examples here of a negative number being squared, but if you were to have something like negative 2 squared and you type this in as negative 2 squared, your calculator is going to say, okay, 2 squared is 4, make it negative. That would be a negative 4 as opposed to negative 2 squared, which is a positive 4. And so you'd get a incorrect result there. However, I'm now going to go ahead and graph this. It's by hand, so it's not going to be perfect, but hopefully you recognize a quadratic equation roughly to form. There we go. Some things about this, you might notice the shape of the graph. It's opening downwards. Fancy word there is just that it's going to be concave down. And then visually you can see, okay, vertex is up here. You may notice it on your graph or in your table as well. It's the center of your table. 3, 4, 1, 2, 3, 1, 2, 3, 4, 3, 4. And yeah, so that's graphing a quadratic equation.